Hi everybody. In this video, we're going to look at setting up and solving quadratic equations, either by factorizing or using a quadratic formula. We'll work through 3 questions, and if you want to work along with me, you can download this PDF from my website. I'll leave a link in the description below. We're told in question 1, now a triangle has a base length of x minus 3, a perpendicular height of 2x, and an area of 18 centimeters squared. We need to find the value of x. To begin the question, we know the area of a triangle is 1/2 of a base times the perpendicular height. We've been given the area of 18, so this will be 1/2 of a base x minus 3 multiplied by the height of 2x. We can simplify this right-hand side by cancelling this 2 with this half, and we can expand out this bracket. So 18 will equal x squared minus a 3x. And now because we have a quadratic, we'll make it equal 0. We'll take away 18 from both sides, and we get x squared minus 3x minus 18. Now it's much easier to factorize quadratics rather than using a formula. So we need two numbers that multiply to make the negative 18, and they add to make the negative 3. So the factors of negative 18, we've got 1, negative 18, 2, negative 9, 3, negative 6, and you can see that the 3 take away the 6 does give us negative 3. So we can write this in factorized form as x plus 3 multiplied by x minus 6. Our solutions then will come from each of these brackets equaling 0. When x plus 3 equals 0, x will equal negative 3, and when x minus 6 equals 0, x will equal positive 6. But we know the length cannot be negative, so we can disregard this solution. So the value of x is equal to 6 centimeters. Okay? Let's try question 2. We're given 2 circles, and we're told that the area of this circle has the same numerical value as the circumference of circle Q. We need to work out the value of a to 3 significant figures. So do you want to try and set up the quadratic yourself? You can pause the video, and when you come back, you can check you're working with mine. Okay, so welcome back if you had a go. If we look at circle P, we're told the area of this, and the area is pi r squared, and the radius is 3a minus 1. So we'll expand out the 3a minus 1, and we'll get pi multiplied by 9a squared minus a 3a minus another 3a plus 1. We can collect these two terms together, so pi multiplied by 9a squared minus 6a plus 1. And we're told that this has the same numerical value as the circumference of circle Q, and the circumference is 2 pi r, and the radius is a plus 2. Now because they have the same numerical value, we'll set these two equal to each other. So the area of circle P is equal to 2 pi multiplied by a plus 2. We can divide both sides by pi, so these will cancel, and then we'll expand out these brackets. So the left-hand side is equal to 2a plus 4. Now because we have a quadratic, we need to make it equal to 0, so we'll move the 2a plus 4 over to the left-hand side. So 9a squared minus 8a, this is the negative 6a, take away the 2a, minus 3, the positive 1, take away the 4, will equal 0. Now we can't factorize this, So we'll use the formula. The value of A will be the 9. The value of B will be -8. And C will equal -3. Now we can substitute these values into our formula. So A will equal minus B plus or minus the square root of B squared minus 4 times A times C divided by 2 lots of A. We can tidy this up. So A will equal +8 plus or minus. This works out to be the square root of 172 over 18. So when we put this into our calculators, 8 plus the square root of 172 over 18. And we get 1.17 to 3 significant figures. We need to try this negative, and we get A equals -0.284. But we know this cannot be a valid solution, because while that remains positive for this radius that would be a negative, and we can't have a negative radius. So our solution is that A must equal 1.17. Okay? Let's try one more question. So do you want to try this question yourself? You're given the area of a trapezium here. This is provided in the exam, as well as your quadratic formula. You can pause the video and come back when you're ready. Okay, so I'll come back if you had a go. So A and B are the lengths of a parallel sides, and we need to add them together. So the parallel sides for our trapezium are the 2x minus 4 and the x plus 5. So we'll add these two together. And then we'll multiply this by h. And h will be this x plus 3. Then we'll divide it by 2. And this will equal the area, which is given as 60. The first thing that we can do here is we can move this division of 2 to the left-hand side. So we've got 60 times 2, so 120. This will be x plus 3, and we'll simplify this bracket, so we've got 3x plus 1. We'll expand out these brackets, and we'll move the 120 to the other side. So 0 will be 3x squared plus vx plus 9x plus the 3 minus that 120. We can collect these two terms together and the constants. So 0 will be 3x squared plus 10x minus 117. Again, we'll use the quadratic formula. So A will equal 3, B will equal +10, and C will equal -117. Substituting them into our formula, we'll have minus B plus or minus B squared, which is 100, minus 4 times A, 12, multiplied by -117, divided by 2 lots of A. This works out as 1,504. So x will equal -10 plus or minus 1,504 over 6. We can work this out on our calculators. We'll divide that by 6, convert it to a decimal, and we get x is equal to 4.80 to 3 significant figures. We'll try the negative solution, and x is -8.13, But again, we know this cannot be a solution because that would give us a negative length here and here. So x works out as 4.8. Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.